Good morning, respected judges. Across India, whether it's a farmer in Rajasthan suffering from drought or the one in Assam facing floods, the question is same. When should I irrigate my crop and how much? A wrong decision means wasted water, high electricity bills, or even crop failure. With agriculture consuming 70% of our fresh water, irrigation is not just a farmer's issue, it's a national crisis. So we ask you a question. Can we give farmers a partner that thinks, decides, and guides them? An intelligent assistant in their field? We are presenting you to an AI plus IoT powered smart irrigation system designed specially for hilly terrains where conventional irrigation is most difficult. Our vision is to save water, increase yield, and empower farmers with intelligent automation. Our solution is a smart irrigation ecosystem that combines IoT sensors to capture the soil moisture, temperature, humidity, rainfall, and tank levels. We made use of AI and machine learning decision models to predict the right time and the amount of irrigation for each crop zone. We also automated drip and sprinkler systems to deliver the water efficiently even on the steep slopes. We also made a farmer-friendly mobile app with AI chatbot for live monitoring, manual control, and the local language guidance. Each crop zone is equipped with the soil moisture sensors connected to an Arduino-based controller. The data is processed locally and the decisions are made by machine learning models that are trained on the soil, crop, and the weather features. The system works in the auto mode, which is AI driven irrigation, along with the manual mode, which is in the farmer's control. A crop intelligent layer allowed different crops like rice, wheat, tomato to be irrigated simultaneously with the crop specific thresholds. Now, talking about its uniqueness and the innovation. We have multi-crop plus multi-region adaptability. We also integrated the drip and the sprinkler irrigation for the hilly terrains. We have AI chatbots for the farmers to support them in regional languages. It works with the solar, rainwater harvesting, and offline Bluetooth fallback, which makes it reliable in remote villages. So, this isn't just an irrigation, it's a complete AI plus IoT farm intelligence system. Now, talking about its feasibility. It works in offline with the Bluetooth fallback, so we are not dependent on the internet. It runs on the solar power, which is ideal for the hilly areas with erratic electricity. The modular design, which is scalable from 1 acre to 100 acres. Talking about the challenges that we faced while working on this, the sensor calibration across various soil types. We have faced challenge while working on the AI models with the local crop data. Also, while working with the initial hardware cost for the small farmers. Talking about the strategies that we use to overcome these challenges, we have pre-calibrated sensor packs for the common soil types. We also have government subsidies along with the FPO models when we talk about the affordability. We also have open source ML models retrainable for the local condition. Now, talking about the setup and the data, we have small farm setup which cost about 20 to 40,000. The medium farms will cost around 1 to 1.5 lakhs, and in the large farm, it will be cheaper as per acre at a large scale. So, yes, it's a feasible, viable, and scalable product. Now, talking about the technologies that we have used while working on this. In hardware, we made use of Arduino Uno, soil moisture sensors, DSG22, rain sensors, ultrasonic tank sensors, 4-channel relay module, and flow sensors. In IoT, we made Bluetooth SC05 wireless module for long range along with the cloud ready integration. In AI and machine learning, we made use of decision tree and random forest for irrigation prediction, future integration of yield prediction, and fertilizer suggestion. In software, we made use of Arduino IDE along with C++ and Python for machine learning training. along with the MIT App Inventor for the mobile app. Talking about the methodology and the flow, we have IoT sensor layer that collects the soil, weather, and the water data. We have AI and machine learning decision layer that decides whether to irrigate, how much to irrigate, and for how long to irrigate. We have controller layer that works with the Arduino and it relays the switch of the pump or the well. We have irrigation layer that has drip and the sprinkler for the delivery of the optimized crop. We have farmer integration layer where we use the mobile app with the AI chatbots. Now, talking about the prototype of this. We have three zones with the soil sensors with drip and the sprinkler valves. We have rainwater harvesting that is integrated into the tank. We have app dashboards that shows the live soil moisture, humidity and rainfall and the tank level of the water along with the pump or the valve status. This makes it a scalable IoT architecture which is powered by AI. Now, let's talk about its impact on agriculture. So, it saves 40 to 60% of the water by precision drip and the sprinkler irrigation. It boosts the yield by 15 to 20% through crop specific thresholds. It reduces the farmer's workload, especially in the hilly terrains. Talking about its benefits, socially, it helps small farmers support multi-crop farming, reduces migration from the villages. Economically, return of investment in 2 to 3 years from the water saving along with the higher yield. Environmentally, it conserves water, promotes rainwater harvesting, and also supports the climate smart farming. So this makes it a triple impact solution socially, economically, as well as environmentally. So our research is based on agriculture sensor integration, which is Arduino, along with the IoT. We also have machine learning models for irrigation prediction that we studied from the IEEE papers. We also studied the case studies on water savings from the precision irrigation. We also made use of reference projects from the IITs and the global smart irrigation agriculture structures and the systems. All these insights were adapted to the Indian context with the main focus on hilly terrains. So, yes, to conclude, our AI plus IoT powered smart irrigation system with the drip and the sprinkler delivery is affordable, scalable, and the farmer first. It empowers farmers in hilly terrains, and beyond this, it saves water, increases yields, and supports climate smart agriculture. So, this is not just an idea, it's the future of irrigation. Thank you. Now, we are going to show you the prototype of our project.
Hello, so I'm here to explain the entire working of this prototype. So let's begin with the app. So these are all the commands to give to this app. And this is the app. This app is connected via Bluetooth and has a very user-friendly interface and command. The prototype works in two modes, auto and manual. In auto mode, everything is automated and irrigation occurs according to the need of the assigned crop. For example, let me just set crop 1 as rice. As you can see, crop 1 set to rice and threshold is 70%. Threshold here means soil moisture levels needed for this crop, that is rice. Now let me set crop 2 as wheat. As you can see, crop 2 set to wheat with threshold 50%. Now let me set crop 3 as tomato. As you can see, crop 3 set to tomato and moisture level needed for tomato is 40%. Now this is the setup we have made to demonstrate step farming, or we can say terrace farming, for hilly regions with drip or water sprinkler type irrigation system. This is the zone 1 for crop 1, this is zone 2 for crop 2, and this is zone 3 for crop 3. These are all solenoid valves to control the flow of water. Now let me just turn on the pump by giving it power. Right now power is not going to the pump, so it is not turning on in auto mode. So as you can see, the pump has been turned on. In default mode, it is set to auto, and as you can see, the pump is on, and because crop requirements are not fulfilled yet, and it won't be fulfilled as there is no soil, so soil moisture is always capturing moisture level less than required, so the pump will keep on working. To turn it off, let me just change mode to manual. The mode has been set up to manual. Now let me just turn off the pump. The pump has been off. Now it won't turn off. To turn it on, I need to give it command again to turn on. The pump started. Now I will show you the rain sensors crop. Rain sensor. So this is the rain sensor. I dropped some droplets of water on it. It detected rain, and so it stopped no matter what. Also, the app has a unique feature of AI ML chatbot that will predict the best time for irrigation for each crop in each zone, and also can predict the best crop to sow. The prototype.
So, judges, what you saw on this last video is not just a prototype, it's the first step of a revolution in farming. This model proves that our idea is not just a theory but practically working. The sensors are already reading, the AI plus IoT controller is already making decisions, and the drip and the sprinkler setup is already saving the water drop by drop. Now imagine this same system scaled up. Actually, terraced field in hilly terrains, across villages, across states, guiding farmers in their own languages through AI chatbots, helping them irrigate smartly, fertilize accurately, and even predict their yields. From this small prototype to a nationwide implementation, our mission is clear: to empower every farmer with intelligent, affordable, and climate smart irrigation. So, this is not just a helping prototype, it's a glimpse of future farming in India. Thank you.